The research project. It's the one subject where you call the shots. It's a clean slate where you design your own course. And it's compared to the rest of the year 12 subjects, it's a breath of fresh air. When it comes to choosing your topic, the universe is the limit. But make sure that you choose something that you're interested in, something that you're passionate about, something that you love to do. Some people actually don't like the research project, and I tell them, if you don't like the research project, then you don't like learning about the thing that you're most interested in, which doesn't make any sense. So, what do I love? What am I interested in? Breaking Bad? But that's not my topic. It's black holes, the real monsters in the universe, which is like Walter White. Now, why did I choose black holes out of everything else in the universe? Well, I'm a physics guy. I love physics, and black holes are at the center of physics. They also encompass all the other topics that I would have done into one nice package. Black hole research is also a continuation of the work of people that I admire, like Isaac Newton, Einstein, Feynman, and so on. We all love mysteries, don't we? Of course we do. And black holes are the greatest mystery in the universe. And speaking of the universe, our job is to understand how the universe works, and black holes may lead us to it. And it may also lead me to understanding my goal of inventing something for myself. Black holes may also lead us to get the theory of everything. What? The theory of everything? What is that? Well, I'll talk about that a bit later. Now, let's talk about my research topic. Here's the long version. How are the laws of nature at risk due to the presence of the black holes, and how can we unify our model of nature to grasp these irrational objects, which will give us a better understanding of the universe? That's nice. But what does this actually mean? Well, our current understanding of the universe is based on the standard model of particle physics. But you see, black holes, they're rogues. They don't work with this model. But why? What's the problem here? That's a part of the question. And to understand them, we need to expand our thinking. To expand our thinking, we need to fuse theories together to form super theories. But how do we do that? What are the steps we take? That's a part of the question. And this new theory, it will give us a better understanding of the universe. How? What will it do? That's a part of the question as well. Now, to answer this question, we have 6 sub-questions, a bit excessive, I know. But the first sub-question is, you introduce black holes. What are they? Where do they come from? Then we go on to, what problems do they cause? How do they cause these problems? Then, who actually cares about this? What's the point of all this? Then we move on to the fourth, where we talk about what things we need to join to understand black holes. Moving on to this, how we do this. And finally, how this improves our understanding of the universe, the theory of everything. And now, to answer these sub-questions, I had to go through so many research processes. I had to read article after article, theses, books from universities. I had to interview nuclear physicists and quantum physicists, do an experiment on logarithmic lensing. I also had to go to university lectures. No, I didn't sneak in. And all of this combined helped me answer these questions. And the most useful was the interview. Now, conducting the research project opened new doorways for me. Like, I would never have actually gone to the Barr Smith Library, maybe next year in university, but never have accessed the National Library of Australia if I hadn't done the research project. And now I have access to so much knowledge that I can put into my other work. It's amazing. But now let's go on to my actual findings. So what are black holes? This is the deep end. So black holes form from collapsing stars. Stars like our sun release light, and this light comes from nuclear fusion. This outward light balances the inward gravitational pull. But when the sun runs out, or any star runs out of fuel, there's no more outward release of light, and the gravity just sucks it in. It collapses the star. And if the star is big enough, it collapses it down to a single point, known as a singularity. Something infinitesimally small, but really, really heavy. The escape velocity of anything from this singularity is more than the speed of light, so nothing can escape it. And the boundary after which nothing can escape is known as the event horizon. The region inside the event horizon is a black hole. Now, what's up with these black holes? What are the problems? Well, yes, they can suck you in and kill you, but that's not the problems we're talking about. We're talking about problems in physics. So Einstein described gravity as the curvature of space-time. So if you imagine space-time, an abstract concept, as a trampoline, and you imagine a bowling ball as the sun, you put the bowling ball on the trampoline will curve down. That is what gravity is in Einstein's mind. Now, if you have, say, a singularity which is really, really small but really, really heavy, and you put it on the trampoline, it will tear through the trampoline, basically tear through space-time. But where does it go? Space-time is supposed to be smooth, not broken. What happens? There's a problem here. Now, one of the most fundamental laws is information conservation. It states that no matter how scramble things, as long as you know the final product, you can trace back to the initial event. Now, black holes, they can evaporate. Yes, they can. They can evaporate into nothingness, as discovered by Stephen Hawking. And when they evaporate, they take away all the information with them. What? Information isn't conserved? That's a big problem in physics. People try to explain this, and they run into other problems like the equivalence principle, and then monogamy of entanglement and such that. And at the center of a black hole, time stops. What does that mean? We don't know. And our equations for black holes, they break down at the center. They give us infinities, which don't make any sense. And the entropy, the disorder of a black hole, is proportional to the surface area, not the volume. And if you were a thermodynamicist, you'd be really surprised. You'd be like, what? No way. Now, what's the deal with this? Why do we care? Well, think about this. The basis behind everything is logic and reasoning. And the building blocks of logic and reasoning are axioms, things that we all accept but cannot prove, like a portion is always less than a whole. And we use this to prove the consecutive findings, and we keep going until we come to our model of the world now. If black holes don't agree with the current model, that means they don't agree with the model used beforehand to prove this. You keep going back and back and back, and you get, nothing's right. We're stuck. Everything we've done is wrong. Now, physicists don't like that. How are we going to advance if everything we've done is wrong? And what's stopping our scientific world from breaking down at any point if everything we've done is wrong? Nothing. So we need to fix this problem. So that's why we have to unify things. Now, a singularity is really, really heavy and has strong gravity, so it's the territory of general relativity, the theory of gravity. But it's also really, really small, so it's also the territory of quantum mechanics. General relativity is the theory of stars, planets, galaxies, all the big things. Quantum mechanics, the really small stuff, the particles, the weirdness that happens in the small level. But when you put these two theories together, they don't mix. These kids just won't play together. Their mathematics just don't work. You just get anomaly after anomaly. But how do we join them together? To join them together, we use string theory. Now, instead of thinking of particles as points or balls, we think of them as strings that wriggle around, and their frequency is what determines what particle they are. And this gives us a D-brain separation explanation of the information loss. It also tells us that, how it punctures through space-time, maybe it leads to a different dimension. And it's all mathematically consistent, I assure you. But the problem is, we can't test string theory. We can't experimentally test it. So, like religion, it's all taken in faith. Some people don't think it's a real thing. So, if string theory, the theory used to explain black holes, is correct, we can get to the theory of everything. Now, as we can see, if you can actually see it, this flowchart diagram. From the start, we unify theories. We combine dynamics and statics to create classical mechanics with atomic theory to create quantum mechanics, and you keep going on further and further and further, and you go to the end, where you have the theory of everything. Now, to get to this, we needed to unify quantum mechanics and general relativity. But now that we have string theory, we can. Now, you're probably thinking, what is the theory of everything? Well, as I found out from my research project, Everything in this universe can be explained with four forces: electromagnetism, gravity, the strong force, and the weak force. You might be thinking, no, it's not. Well, think about this. Why does life exist? Because cells form. Why did cells form? Because the cell membranes form. Why did the cell membranes form? Because of electrostatic attractions. Why is the universe structured? Because of gravity. Why do atoms exist? Because of a strong nuclear force which hold the protons together in the atoms. So if we have a theory of all forces, we have a theory of everything. Have I answered my research project question? Of course not, because there's way more stuff left. The objective of the research project is to give you the skills necessary to do well in university. Some of these skills, some people do not have. I've developed skills like, properly in-text referencing, evaluating sources, evaluating myself, proper time management. You have, critically analyzing the sources. The word limit helps with that. Then we have improving my academic tone, making the writing as academic as possible. Then improving in skills such as communication. You have more understanding of mathematics, visually thinking about things, creative thinking, literacy skills, and so on. These skills will help me in the future. And speaking of the future, I do plan on continuing mathematics and physics at university. And I'll probably do a PhD, and I wish to go to NASA or CERN to continue my research in black holes. So this research project has started my journey to answering my question with my own hands. One day, maybe in 10 years, I'll answer my research project completely with my own hands. And this is what started it all. Thank you.